Hi, it's Jan from FPC, and in this video, I want to show you how you can use digital input and outputs in your test sequences. The purpose of using digital IOs is to control and read the status of your test set. First, let's verify the digital IOs we have for this setup are wired up properly. To do that, we'll go to the Device tab and double-click on our IO device. Here, I can see all the digital IOs I have available. As you can see, I already have named two digital outputs, fixture and DUT, and one output, power VCC. The fixture input is to monitor if the fixture is open or closed, and similarly, the DUT pin is to detect the presence of DUT. Now, let me switch a camera so you can see the actual test setup I have, and we can verify if our IOs are working as expected. Now, if I close the fixture, I should see that both of the digital inputs change states when the fixture closed. And if I remove the DUT from the fixture, I should see that only the fixture digital input is detected. Similarly, I can manually trigger my digital outputs to on and off to verify their proper functionality. So everything seems to be set up properly. So we can go ahead and implement these digital IOs to a test sequence developed in one of the previous videos. Now we will go ahead and open up our test sequence file. The typical usage of digital input and outputs in a test sequence is to verify that the test setup is in the right condition to begin the test. First, we want to create a condition that only when the fixture is closed, our sequence will execute. To do that, we can utilize a front test command called catch IO and specify that only, or first we specify that we want to read the digital input, which we call fixture, and we want to only accept when that value is logical 1. And now, when we run this test step, the test step keeps executing, which essentially pauses the test sequence. And unless I close the fixture, which I'll do this right now, the test step is successfully executed. So this will make sure that the test sequence will be only executed when the fixture is closed. And now we want to create our second condition. We also want to verify that there is a DUT in the adapter. Here we'll do the other way you can implement IOs into your test sequence. We'll utilize the column called IO, where we similarly will read the pin alias with DUT. And that's the only thing we're going to do in this step. So if I now place the DUT in a test fixture, I'll close it and run this test step. It will return 1, similarly to what we had in our previous step. So if both of these conditions are met, everything is good to execute our test sequence. But let's say our DUT is not present. So if I do the same test step again, now the return value is 0. If this is the case, I want to display instructions to the operator, inform him that there is no device under test, and prompt him to insert it and correct the action. To do that, we will first display him a message that there is no DUT in the adapter. So for that, we'll simply say no DUT in the fixture. And after that, we want to make sure, or the logical next step would be to open up the fixture so the operator can insert the DUT. So for that, we will use the catch IO command again. But in this case, we will use the reverse. So we want to make sure that the fixture gets open. So when the message no DUT in the fixture gets displayed, the execution will be paused until the fixture is open. And after it's open, you want to go back to the beginning of the sequence where it prompts the operator to insert the DT and check the two conditions we just defined. So we'll just use the command goto and go back to start. And we don't want to execute these every single time. We want to execute them only when the DT is not present. And in order to create this condition, we can use the exec column where we can create a spreadsheet formula where we can say if the value of the previous step, where we're checking if the DUT is present, if it's 0, we want to execute these steps. So if this go to 0, hang on a second here, if this is equal to 0, we want to display 1, which would mean that the test steps will get executed, or otherwise we want to display 0. And we will do the same thing for the other test steps. So now I can test if the logic behaves as expected. So if I run these test steps again, I will start with waiting for the fixture to be closed, and I will, in this case, insert the DUT, run the test steps. I can see that the exact value now for my corrective action in test steps is 0. Therefore, they will not get executed. And now I can go ahead and execute the test sequence from the operator interface to verify that it works as expected. First, we'll follow the nominal case scenario where we insert the DUT and close the fixture. So now the test should perform as expected. We'll connect power to the DUT and finish the test. Now if we restart the sequence, but this time we will not insert the DUT. So when I close the fixture, it should prompt me that no DUT in the fixture, acknowledged, looking up the fixture, and it will jump back to the beginning of the test sequence. And when I insert the DUT, it will go ahead and execute sequence as planned. Now, let's say we want to automate even more of it. And as of now, midway through the test sequence, we have a manual test step to manually connect the power to the DUT. To automate it, we can utilize the digital output that we specified at the beginning of the video, where we can utilize the column IO again. And instead of reading the digital input, we'll set digital output, which we labeled the power underscore VCC. We'll get rid of the dialog window, so we don't anymore require any manual operation during the test sequence execution, speeding up the test sequence and also minimizing any human error. So if we do the same thing again, open the fixture before the sequence starts, now run the sequence, the result will be the same, but no more manual actions are needed from the operator. Essentially, the only thing he or she needs to do is to insert the DUT and close the fixture. So these are the basics, how to utilize digital IOs in your Fontes test sequences. We'll be covering more in the upcoming videos. But if you're interested in learning more, visit our website and contact us to get started. Thanks.